vectors. Do you write this down? Yes, yes. Wake up, wake up. How did you get to school? Taxi? Walking? What did you do?
I came here by taxi.
Nice. Taxi?
By Lewis.
Lewis?
Yeah. I look at.
Oh yeah.
No.
Walking, okay, yeah. Which Lewis? Red or green?
Green line.
Green line. Okay, so you got off at Harcourt and walked from there.
Yeah.
So how long did you take to walk to the Lewis stop from your home?
20 minutes.
That's okay. So why don't you take the Lewis every day? The bus is quicker?
Bus is more quicker.
It's quicker. It's cheaper.
Yeah.
Yeah, okay. Alright, did you write this down? Resolving vectors?
Yes.
Yeah, okay. Right. So we're kind of looking at perpendicular vectors. Horizontal and vertical vectors. Do you know these words? Horizontal? Yeah, you know them from math class. They can be added together just like normal vectors. They're not anything special. But this is actually a common problem in mechanics. So it's quite common in mechanics to have a horizontal vector and to have a vertical vector and then to add them together. And of course in this example it would look like this is the answer. If this is the horizontal and this is the vertical, this is the horizontal plus the vertical. Yeah. So that's not special. In fact, you did something like this in your homework. Okay. But what is special, and what we're going to do in the first lesson, is what's called resolving vectors. No. It's a verb. And it means to take the resultant vector, this is the resultant vector, remember, and from the resultant vector work backwards to the horizontal and to the vertical vector. So in other words, reverse the process of taking the resultant and then reversing it back to a horizontal and vertical. This verb is resolve. That's what it means. So you might want to write that down. It's a word that you will definitely need for this course. I will use it a lot. Resolve the vector. Okay, so please write this. You can write a definition or you can just draw this or whatever, but I need you to make note of this word resolve. Is this a new verb or have you heard this verb before?
Resolve. Yes.
Resolve? In English or Arabic? Oh good, okay. Yeah, okay. Andy, is this a new word? Is a new word? Okay, good. And what about for you?
Yeah, I think so.
Yeah, you write the definition down? Yeah. Okay, so this is resolving vectors. Continue? Yeah? Okay. So, the reverse is called, where you take a vector and write it as its sum into horizontal and vertical. As I was saying, that's called resolving, going backwards.
A plus B square, A square plus B
That's-
square equals C square.
That's where we're getting to next. Yes, this is to resolve the vector. You need to have two formulas. The first formula was actually in the homework, something you should remember from middle school, called Pythagoras. So, how is this formula useful? Well, this formula is useful because it can help you find one of the missing sides, or usually it's used when you know these two sides and you want to find this side here. A squared equals B squared plus C squared. You all know this one, but maybe you didn't know his name. So can you write this? Just draw this, but make sure you write the title, Pythagoras Theorem.
So what's the definition of resolving?
Oh, I didn't really give you a formal definition. If you want a simple definition, resolve means to take a resultant and to write it as a horizontal and vertical vector.
To take a resultant and
rewrite it as a horizontal and as a vertical vector. Sum. Sum just means you add them. Okay, we got this drawn? Yeah? Pythagoras. Is it still Pythagoras in Korean?
Yeah.
He's called Pythagoras still?
Yeah.
And in Arabic he's Pythagoras. So, yes.
Pythagoras.
Oh, Pythagoras. Okay, okay. Right, continue.
Yeah.
Yep. Ah, oh, come on. What classes do you have after lunch today? You got a busy day?
No.
Nothing?
There was physics and we had extra math before, but we don't just didn't today. So
Oh, so you have a half day.
yeah,
Nice.
We are not having,
no,
but it's written in.
it's extra math.
The extra maths is only for some people. You can go to it if you want.
Roland told me yesterday that it was for us yesterday.
Yeah.
Today it's just business. He said that.
So we had in the extra history.
No, it was your choice. He said it's not mandatory.
Yeah.
If you wanna go, you can
Yeah.
go on and score.
So we are not in the extra class. We are not doing the extra work. It's the same.
Yep.
Yeah. Okay.
Yeah, yeah.
We are not following the course.
There's not new things in it. You didn't miss anything. It's a resource class.
Okay.
Yeah. Okay, continue.
Yeah.
Yep. Right. So you can use Pythagoras to find the magnitude, as I was saying. Right. So here's a simple example. What is the magnitude of the resultant of 3 meters east and 4 meters north? Yeah, I think I'll let you try this really quickly.
5.
It's 5, and you can probably even recognize it as a famous triangle. The horizontal is 3, the 3, 4, 5 triangle, yeah. So for this example here, you have, what did I say, 3 meters east, was it? 3 meters east, 4 meters north, and in fact if you're familiar with your triangles, you might remember that this will be 5 because x is square root 3 squared plus 4 squared, which is 5 then. Yeah. Okay, there's nothing special there. Now I definitely want you to write these names down. They're the names of the sides. Just before you do, just let me clarify something. If the angle is here, we call this side the opposite because it's opposite of the angle. But if the angle was here, this is the opposite.
Yeah.
So the opposite is always opposite the angle. Number 1.
Okay.
Now, the hypotenuse is always the longest side.
Its place doesn't change.
Yeah. It doesn't matter if the theta is here or here, the hypotenuse is always the longest, and therefore the adjacent is what's left. The adjacent is beside the angle, it touches the angle, okay? Now, in English, you might know the word opposite, of course it's opposite, but does anyone know the word adjacent?
No.
No, adjacent means beside, neighbor. So, I could say, he is beside him.
It's into him.
Yeah, but it's the same to say he is adjacent to him. So adjacent is a more academic word for beside. So it will help you write in using a word like this than just beside or neighbor. Yeah. Adjacent. So please draw this. Okay. Oh, and of course, I think you all know this, but what does this symbol mean? This
This is
90 degrees, yeah. You got that drawn? Yeah. Did you know these words already? Yeah.
But I have hypotenuse, base, and it's one more thing. But they are same.
Height maybe? Altitude?
Hypotenuse, the adjacent we call base, and this one is perpendicular.
Yeah. Perpendicular height or perpendicular?
It's the perpendicular is opposite to that. This
Okay.
Opposite we call perpendicular.
You just call it perpendicular,
Yeah.
okay. Can I continue? Do you have this?
Yeah.
Yeah. Okay. Now, there is something which we can use on our calculator to find the angle. Now, this is something you will do in math class, so it's not for me to spend a lot of time. For me, I'm just going to say it's a thing that you do on your calculator. I'm not going to explain the whole idea behind it. That's what you'll do in math class. So, if you look at your calculator, there should be a button called tan. Yeah, and
minus 1.
shift tan. Yeah, that's it. So if you type in tan inverse the opposite divided by the adjacent, the answer on the calculator is the theta here. Okay, so what we have so far now in our triangle, we'll call this A, B, C, for example. We know that C squared equals A squared plus B squared, and our second formula is that theta is tan inverse B over A in this example. Okay, so just make note of this, or, well, I prefer if you write it like this, beside your picture. So this gives us the angle, the direction. Yeah? Okay. Continue? Mm-hmm. Okay. So that is the theta. Okay. So if we go back to our example from earlier, our 3 and 4 that we have from earlier, now I would like to calculate the theta. So the theta will be tan inverse 4 over 3. Which I think is about 53.16? Close enough. 53.13, so 0.1 degrees then.
So it's 0.97. 0.92.
Your answer? Are you in like radian mode or something?
On degree.
Yep. Gimme. I don't like these graphing calculators. See, I think you're in radiant mode. Do you know radians? You need to change it to degree mode.
But I don't know how to change it.
I definitely don't know.
He will reset it, then it will be, in the...
No, his graphing calculator's default could be radiant.
Yeah.
Even if he resets it. Yeah. This is why I don't like graphing calculators. They're difficult.
I had this calculator. Well, which one? The one with...
That one there
I
is
know,
the best one.
But I have one, but I lost it.
Oops.
So
Well, buy a new one.
If we will multiply it by 0.1...
Yeah, but that's messy.
That will,
Just get a nice calculator, okay? Alright. Anyways, is that okay? There's a theta there. Now, you'll do this in maths, but we have some formulas which are useful for us. So we have...
write this one?
Yeah, I want you to draw this. So before you do, let me just look at the formulas. We have something called the sine of theta. The sine of theta is opposite over hypotenuse. The cos of theta is adjacent over hypotenuse, and the tan of theta is the opposite over the adjacent. So if you know the theta, you can use your calculator to calculate sine theta. That means if you know this one, then you can know this one. Or if you know this one, you can know this one. Yeah, which we'll look at in a minute. But for now, I just want you to draw this. Yeah. You've got the 3 formulas? Yeah.
we are having only one class or two?
No, we'll have the 2, yeah. There's not a lot to do in this first lesson because it's just basic. I think Turkey changed his mind.
About
He was biology and then he's engineering,
You want?
but I think he's gone back now.
really.
I think so. That's why he's not here now. But I don't think he's gone to any physics class.
Well,
So I didn't even give it a chance. Turkey, you know Turkey?
yeah,
He was science,
I know.
now he's engineer.
You told me.
Yeah. I think he's back to science. Yeah, that's my point. He went science, engineering, and he went back to science so quickly. He never saw him in engineering.
He's so confused about.
What to do?
Yeah. He's nervous.
Is he worried that physics will be too hard?
He's worried about everything.
Oh, okay. Well, not much choices then, really. What does he want to do? Do you know what he wants to do?
The main idea was
he's
be a
told-
criminologist at first. That's what he said.
But his mother wants him to be, I think, medicine.
Yeah.
Study medicine.
Yeah.
Every mother wants their son to be medicine.
Very true.
But every son should be an engineer. There is a concept for us that every son should be an engineer.
In Pakistan?
Yeah.
Okay, alright, yeah. Well, he's from, where's he from?
Saudi
So
Arabia.
definitely every mother wants their son to be a doctor in Saudi Arabia. Definitely. Okay, do you have this?
Yep.
Yep. Alright. So note that often we know the magnitude, which is the hypotenuse, and the direction. And what's the direction? The theta. So usually that's what we know. And basically we want to know the magnitude of the adjacent and the opposite. So I'll show you how you can do that. Let's see how. So you'll need to write this down. So if you just watch carefully. So let's imagine we have a vector and we only know the magnitude. So I'll call that, I don't know, or its magnitude. And I'll call the angle here theta. And what we want to know is the magnitude of the horizontal, which I'll call x, and the magnitude of the vertical, which I'll call y. Alright. So, let's just to be clear, the or we know, and then the theta we know. These are the two things we know. Okay. So I could say, well, sine theta, do you remember the formula? What did I say it was? Opposite over hypotenuse. Now if you look at this, which is the thing we don't know?
We don't know the y.
The y. So we can say y equals or sine theta. Yeah? And we know this and we know this. So now we know the y. Likewise, we can say cos theta equals x, adjacent over hypotenuse. So we can say that x equals or cos theta. That means if you have this triangle, this vector, let's say, we'll say it's 10 here and 20 degrees here, I can very quickly get the horizontal and the vertical. This side, using my formula, will be 10 cos 20 degrees, and this side would be 10 sine 20 degrees. Okay. Now you're expected to do this, automatically. So if I give you some vector, if I draw it like, there could be like some wall here, and then maybe there's a vector here, and this is 20, whatever the unit is, and I say, okay, I want you to resolve it into the horizontal, in this case the vertical, and the horizontal, and I put the angle here, let's say that's 60 degrees. Here's my tip for doing it quickly. First, you start with the side that touches the angle. So does the vertical touch the angle, or does the horizontal? The vertical. Yeah. My trick is, look at the angle, the side that touches the angle. That is always the cos.
Yes.
Always the cos. So this side would be 20 cos 60. And this side would be then automatically, it must be 20 sine 60. So my trick is the cosine goes with the angle. Okay, so because this one touches the angle, this is the cosine one, and therefore this one must be the sine. Now this is a very useful trick that will let you resolve very quickly. Okay, so I don't know if you want to write that down, I don't know if you want to, but you definitely need to write this down, and maybe if you can write down my trick as well. My trick.
We have done this, the cos goes with the x.
I prefer to think of it as the cosine goes with the side that touches the angle. That's how I think about it, rather than opposite and adjacent, because you can get a little confused sometimes.
No.
Yeah.
But you please show.
Oh, back here?
Yeah.
Yeah.
So it's the sine.
This one?
Yeah.
No, trust me, it's the cos.
Because it's on
No,
the
trust me.
Yeah,
You don't trust me.
I trust you, sir.
So watch. Because you don't believe me, that's okay. Watch. If I call this side, this one, I'll call it x, and I'll call this side y. Yeah?
Okay.
What is cos of 60? The adjacent, and what's the adjacent here, x or y?
Y.
It's cos 60 is x.
No, because x is called the opposite.
Okay.
Because it's opposite to 60. So therefore the y is called the adjacent. Yeah. So cos 60 is the adjacent over, and what's the hypotenuse? 20. So then y is 20 cos 60. Yes. Yes. Yeah. So this is why I said my trick is useful here. Try not to think about opposite and adjacent. Think about cosine goes with the side that touches the angle. It's much safer that way. What's happening out there now?
Yeah, have a weekend maybe.
Yeah. Weekend starts early. It's not even 12 o'clock. Have you seen it this way before? This trick? No. It's very, very, very useful. It's a big time saver. Cosine goes with the side that touches the angle. Yeah. It's okay? Yeah. Okay, continue?
Yes.
Yeah.
Okay. So, next now. Right, so we can now give a formal definition for speed. Speed is the magnitude of the velocity vector. Yeah. So for example, let's say, let's go back to our example up here. So let's just change this into somebody goes 3 meters per second this way and 4 meters per second this way. So in total, they're going 5 meters per second this way. Just to be very clear, we can say that their velocity is equal to 3 meters per second east and 4 meters per second north. That's their velocity, but their speed is 5 meters per second. That's their speed. So velocity is the x and y basically, and the speed is the magnitude. So the definition is speed is the magnitude of velocity. So if you can get this definition, speed is the magnitude of velocity. Yeah. I don't remember if I said that already, did I? Or no. Speed is the magnitude of velocity. Okay. Continue? Yeah? Okay. So here's an example. I suppose I kind of already did this, but I'll let you try it then. Let me just see. No, that's okay. That's too easy. I think this is much more important. This one's a little too easy. This one here, I just say it goes 10 meters east and 20 meters north. What's the magnitude? So that would be square root 500. 10 squared plus 20 squared is 100 plus 400, yeah. It doesn't matter, it's not really important. Square root 500. And then what would be the angle here? It'd be tan inverse 20 over 10. Can you picture that? I'll just very, very quickly do. Yeah. This is 10 and this is 20, so this one is root 500, whatever that is, 7.
20 over 10?
Yeah, and then the angle, theta, is tan inverse 20 over 10.
It's 1.1.
I'm not in your calculator. What is it, 60?
3.43.
Yeah. I mean, so it's very straightforward. And what I want you to try is really this one, okay? Try this one now for me. Do you remember what bearing is?
Bearing, it's you told us. You told us the meaning of bearing.
Yeah, what?
It's
What? Which do you measure from? North, south, east, west?
South.
No.
East.
I know.
It's
You're running out now. 30 degrees bearing means 30 degrees from the north clockwise.
Yeah, clockwise.
Yes. Yeah? 30 degrees clockwise from the north. So for you it looked like this. Yeah. Okay, try this. Okay, do you have it? No? Okay. For let's calculate it now. Okay, so let me just put in my compass. Right, so it's going 15 kilometers per hour. and the angle here is 30 degrees. And I want to know what is the, well, vertical and the horizontal. Some of you maybe drew it this way and this way, which of course is fine because this vector is the same as this vector, so it doesn't matter. And if you did it this way, maybe you felt like you should call this 60. But it's not necessary, but if you did that, that's fine. I'm going to keep it like this. So which side is, what will this side be?
Adjacent.
Yeah. Well, let's say opposite and adjacent. Is it the cosine side or the sine? Cosine. So it'll be 15 cos 30, and this side is 15 sine 30. So what's 15 cos 30?
12.99.
Okay. So north at, what'd you say, 12.99?
Yeah.
So 13, we'll say, kilometers per hour. And then west at 7.5 kilometers per hour. So this is the velocity of it as a horizontal and vertical vector.
That's 7.5, I think.
Typed it in wrong, maybe?
Yes, maybe. That is 16.
That's okay, isn't it? This, yeah?
Yeah.
Okay. Now I'll leave this here for a second. I just want to check what's next. So we have that, and then have the homework. Okay, so what I'll do is, I'll leave this here. I'm going to go off to refill my coffee, and then when I come back, we'll start the next lesson. But while you're waiting, if you want, you can have a start on the homework, because, again, I think there's 6 questions, and they're all like this. So if you spend 1 minute on each question, you can get them done in 6 minutes, and then there's no homework from it, okay? All the questions are like this. You have to resolve. For example, the first one is the angle is 30 and the speed is 10. And here the angle is 45 and the force is 50. Again, yeah. So you could finish this in 5 minutes, okay? So you can open it up on Moodle, or do you need me to leave this here?
No,
You need to do. Or, well, maybe you can just copy it from someone then, and I'll leave this here for you to do, okay? So 5 minutes, and then, what have we got coming up next? Now we're on to velocity and time graphs. So that was the last lesson on vectors, okay?
Can I go to the bathroom?
Yeah.
You can, just make sure you're back before me. Yeah?
I hope so.
Well, I need to make a coffee, so I'll be 5 minutes, please. And, will somebody stay in the room, or do I need to lock the door? Yeah? Okay, well, I'll leave it open then. Because my key is there, so if we all leave, we'll be locked out, okay? So don't do that.
Very good. You? Oh. Okay. That's fine. That's okay. East to this side.
This side?
Yes. How much? No, I'm asking east.
East what?
If I can,
East to this side.
east
Yeah.
is right. East
Right
is
side.
right.
I'm asking this.
So that's fine. Yeah, I'm doing fine. Thank you. Open the book.
بالظبط بالظبط. المدرس باشمهندس بتاع الجو.
I'm fine. Okay. How about for me?
Get them finished?
I'm on
Some
four.
of them, yeah.
That means no. Alright, we'll continue.